in East African savannas.
Okay, thank you for coming and letting me say something this afternoon. I'm just going to give you a little overview of some of the work that I've been doing in the biology department in Tanzania. And the focus of my research there is on the processes that shape savannas. So I'm going to focus on fire and herbivory within Tanzania. This is what I'm just going to cover in the next 15 minutes or so. I'm actually interested in distributions, and the distributions of species, why they're not everywhere. So that's where we're going to start, since that's what took me to Africa in the first place. And I'm then going to say that you can't understand those distributions in Africa without understanding some of the fundamentals of savanna ecology. I'm going to describe some of the experiments that we're doing at the moment in Tanzania and elsewhere. And then I'm going to finish just by showing that we can not only restore forests, but we can also start restoring degraded savannas. And that's a new project that we're just kicking off in Tanzania at the moment. So an ecologist safari in Africa. This is the question that interests me fundamentally. As Darwin explained a long time ago, he asked, who can explain why one species, such as this common quail, ranges widely and is very numerous, but another closely related species it has a narrow range and is rare. And it's a fundamental problem that has very difficult to answer. But we know some things about it. We know that climate is certainly part of the story. As places get too cold for one species, you might swap into another. We also know that the biotic interactions, competition, predation, shared pathogens, that sort of thing can also be really important in shaping distributions. But it's when species distributions start changing that we can try and get an understanding of what was limiting their distribution in the first place. And that's what sent me off. This bird on the right-hand side here, this is the spotted mourning thrush, and I think it's a new pin-up for climate-driven changes in East Africa. It's moved 300 or 400 kilometers westwards as the dry seasons have changed in Tanzania. It's crossed the rift, some major barriers to dispersal beforehand. So as we're seeing these changes, maybe we can understand some of what's going on. Okay, so happily in Tanzania we have an awful lot of data that have been gathered by guides taking tourists around, and the guides tend to be very skilled, and also a whole bunch of volunteers who are also quite well experienced ornithologists in Africa. And it's allowed us to model the distribution changes between about 1960 and 89, quite a long time ago, and then post-2000. Because we know where the guides and the volunteers go, they tell us what they see and how often they visit each area. We're able to fill in the gaps between places where we haven't seen a species because it hasn't been looked for there, versus where the species hasn't been seen despite an awful lot of effort. And so we're able to put together maps like this one on the left-hand side that this says this is the presence of a species. In this case, I think it's the Fisher's sparrowlark across savannas in Tanzania, with the red cells places where we've actually seen the species, the black cells spaces where we infer from our modeling that the species is probably there because the habitat is the same, the climate's the same. It's very close to a place where we know it is, but we just haven't been often enough. And the ones with total absence or very tiny things just have a very low probability of them being there. So we're filling in some of the gaps with the big black squares. And then we can look at how that changes over time. And on the right-hand side here, we can see for an individual species that it's moving west. This is the same species. These red cells, again, are places where we've actually seen the presence of this species in the new period, and it wasn't there beforehand. There are also some black cells where the inference is still that it should be there. We just haven't visited that one quite enough. That's a small island in the middle of Lake Victoria, which is quite hard to get to, that gives us that cell there. And the background in this one is the change in the climatic suitability. Once we've looked at the climate that defines the species range in the original thing, we can then say, well, how has that changed over the last few decades? And here, for this particular species, everywhere in Tanzania has got a little bit closer to the climate that it liked in this range beforehand. So it's gone, everywhere is basically blue, but the darkest blue places are where the current climate has become more similar to the core of this range and changed favorably most for this particular species. And you can see that the dark blue areas tend to be the areas that have been colonized. So we've got a fairly good idea that this species is following changes in climate to that west area, and it's all to do, in this case, with the length of the dry season. And we can see that this has changed. So that's just one species, but we've actually done this for 139 different species that live across the savannah, and we can look at the cells where those colonizations or extinctions have happened. And so here, this is for cells where the species was present. A 1 indicates present in the first time period, and on the right-hand side, it was present throughout. So it was didn't change, and the climate suitability is defined here. For these ones, the species was present, but it's gone locally extinct. And there's a wide range of climates associated with that sort of behavior. Whereas those cells where the species was absent, but have now become present, so colonization across all species tends to be in much more suitable areas, so well to the right of everything else. So we get a good indication that across this whole suite of savanna species, the climate is driving the patterns of colonizations, but not so much the patterns of local extinction for these savanna birds. And actually the really important comparison is between those cells that have been colonized, so this type of cell, and those that haven't been colonized, and whether the difference in those things is important. So you can see cells that have been colonized tend to be slightly more suitable than the cells that haven't been colonized. And this is just those comparisons there, confirming that across these species, there's a dominant signal of colonization in association with changes in climate. The same isn't true for the extinctions, but we can overlap both the colonizations and the local extinctions, not only with climate, but also with protected area and various other things. And broadly speaking, we discovered that climate change seems to be driving patterns of colonization. The extinctions, local extinctions happen where degradation is greatest. And protected areas are both preferentially colonized. As a species is moving, it likes to jump into a new protected area. And they're also the areas that are least degraded. So protected areas seem to be working within this landscape for savanna birds, even though we don't set them up with that in mind. But it doesn't tell us anything about what the mechanism is. We know that climate's somehow related, but these species aren't measuring the length of the dry season and saying, okay, I'm going to go there, it looks good now. They're responding to something much more proximate. And that's what the next problem is. And to understand what really drives distribution change, you have to then take a step back and say, let's understand something about the savannah. And I'm going to introduce you to the big four, which are the big four processes that shape savannas. At the bottom, we have water availability, so the rainfall and the soil capacity for holding that water, and the nutrient content that comes out of the rocks that underlie the soil or in the soil one way or another. That's the underlying thing. On top of that, we have herbivory and fire. These are the big four processes that shape savannas, and they all interact one way or another. So where there's lots of water, you start to wash away nutrients. You also encourage fire by making those sorts of things happen. Nutrients and herbivory are very closely linked, both ways, both backwards and forwards, but also fire shapes herbivory. Herbivores love to come into those new areas of where there's been a fire, fresh new growth. They'll come piling in immediately after a fire and eat that new growth. And they'll be fertilizing the thing there. But equally, if there are very large numbers of herbivores in the landscape, they're eating all the grass that the fire normally happens. So as you get more and more herbivores within a landscape, you tend to get less and less fire. So this set, the big four processes, are all very interlinked and have quite a dynamic system within the savannah. And what we've seen happening recently, of course, is climate change. And its primary effect within the savannah, within East Africa, in fact, is a water availability thing. So once you start pushing on water availability, you can see that we're going to change all these other processes within the savannah. And so from my interest originally in birds and their distribution shifts, trying to explain that, I've got to try and pick apart some of what's going on here. And then also, because I'm interested in that, how we might try and mitigate some of those changes. So the main thing of those 4 processes that we can manage is fire. So we've been setting very large experimental burns up to several thousand kilometers square, which is great fun. And we're burning them at different seasons and with different frequencies across the Serengeti landscape. We're trying to identify some of the ways these different processes, the herbivores, interact with fire against the background of water availability and soil nutrient. And we're looking at conserving the ecological processes. We're also doing some experiments where we're excluding herbivores across the landscape. And this is one of our this is actually an insect herbivore exclosure, which we also have mammalian herbivore exclosures in the same areas to compare those sorts of things. And we can combine this with information about the large-scale patterns of fire. So what we're seeing here is the Serengeti ecosystem. This is actually Serengeti National Park. This is the Ngorongoro Conservation Area, the Kenya-Tanzania border, and into the Mara National Nature Reserve in Kenya. And the red patterns are the frequency of fires here in the early dry season, here in the late dry season, and the other important period is during the short rains, the short dry period around about January, February. And we're trying to understand how the history of these things within the context of our experiments shapes what's going on too. And we've been looking at some of those things such as the number of short burns, the fire history in relation to the diversity of bird species that occur in these landscapes across Serengeti. And we find the sorts of patterns we might expect. And then we've been trying to take a little step backwards, looking at what we define what we're calling pyrodiversity, using data on mammals and birds across Africa and the MODIS satellite products that tell us something about fire. They tell us information from which we can extract the intensity of fires at a 500-meter resolution across Africa. The area of any individual fire, whether it burns for tens of kilometers, just a tiny little patch, something like that, how frequently a place burns, what the interval is between fires, whether it's burning every year, some areas are burning more than once a year, or whether it's taking 10 years before the fire comes back. And then the season that it burns. Does it burn in that short dry season? Does it burn in the beginning of the dry season, the long dry, or later? And these 4 axes we can plot essentially in multi-dimensional space and measure the volume of fires. So if you imagine each one of these axes is an individual fire. You draw a ball in multi-dimensional space within a grid cell and say the fires that have occurred over here in the last 20 years fit within this large diverse area, or sometimes they're all in a little tiny corner where they're always, this particular cell always burns in early May, burns every single year, and they're small fires. So that you can measure the diversity on all these different axes. And then once you've got that, you can start mapping it across Africa, which is what we've done. That's the savannah thing, and we can see that pyrodiversity is highest in some of these darker green areas around the dry fringes. And we can then relate that to the diversity of species across the continent. We know that across the continent, the species richness is largely driven by energy, but once we've explained that, looked at those things, we find very, sometimes quite strong relationships between the richness of these bird species or mammal species in relation to the diversity of fire that is happening in an area. So that is telling us something about pyrodiversity and its impact on ecology at the continental scale. But all of this information we've been gathering about the sort of fundamentals of fire and herbivory within the savannah obviously has some much more applied basis, because there's an awful lot of land degradation There are something like 30 million people living in East Africa's savannas who depend on those savannas for their livelihoods, for grazing in particular. And in some areas, it's very, very badly degraded. So we've just started on a big project as part of a much larger project, in fact, funded by USAID, setting up experimental restoration plots across northern Tanzania, where we're trying 5 different treatments that local villagers could apply to their land to test how well that restores degraded areas within the landscape, based on the understanding we have of the big 4 that's doing that. And I've got a postdoc at the moment who's busy setting up those things, hammering posts in grounds and buying goats to graze the areas as well, which is great fun. So that's just a sort of overview of the diversity of some of the things that I do. There's a lot of people who have been involved in this. This isn't all of them, and quite a lot of funders who pick up various bits and pieces. So just thank you all for listening. I hope I kept time there.
Yes, no.
Yeah.
It's a very nice contrast from the lowlands. Questions for Colin? Andy?
What are your restoration methods then?
So it depends. Degradation within a savanna goes one of 2 different ways. You either turn into a dust bowl with nothing, no vegetation, or just a few toxic, noxious